All right, welcome everybody to our Backyard Natural Resources series. This is day two. So we did have a presentation on Tuesday on soil health in the garden. So if you missed that one, you can catch the recording on YouTube. And if you're not able to join us next week for grasslands and biodiversity on Tuesday and Thursday, those recordings will also be on YouTube as well. And for folks that maybe haven't met me before, my name is Amanda Bachman. I'm the pesticide education and urban entomology field specialist based in Pierre, South Dakota. And I'm here during the noon hour-ish to introduce our panel and give you a few tips about the Zoom. If you have questions at any time about the content, feel free to put those in the Q&A at the bottom of your screen. If you have tech issues or need help with something, feel free to raise your hand and one of us will message you in the chat. You can keep an eye on the chat as well for links to some of our resources. And then at the end of the presentation today, we'll have time for more questions. And we also have a few surveys for you to fill out to help us gauge interest in programming and get ideas for future programming. So we'd really appreciate it if you would fill those surveys out. But right now, I will turn it over to Robin Butterbaugh, who is our horticulture field specialist based in the Sioux Falls Regional Center and also in Brookings. She kind of goes in between the two. And she's going to introduce our featured speaker. So Robin, I'll hand it to you.
Okay, thank you very much, Amanda. Well, I'm really pleased to be able to have John McMaine with us here today. Dr. McMaine is is an endowed Griffith Chair in Agriculture and Water Resources, the director of the Mesonet at South Dakota State, and director of the South Dakota Water Resources Institute. So he's a very busy guy. Dr. McMaine is passionate about solving challenges related to water and weather in South Dakota and across the Northern Great Plains. He sought to work across traditional divides, such as urban versus rural and environmental versus agriculture, to solve problems around a resource that we can't live without, that being water. Professionally, his greatest joy is found in building relationships to facilitate progress and change, and as a result, he seized the opportunity to work with individuals and organizations across the agricultural and environmental spectrum. For Dr. McMaine, it's never us versus them, but rather how can we work together for the good of all. So with that, I'm going to turn it over to Dr. McMaine, and he's going to talk to us all about water in our backyards. Thank you.
Awesome. Thank you, Robin, and thank you, Amanda, for this invitation to share a little bit about water around the home and really what we can do as homeowners or as really people that maybe we think we have a small impact, think about the impact that we can have. So I'm going to share my screen and we're going to kick off the presentation. So I'm going to spend a fair amount of time today talking about rainwater harvesting and rain barrels. And then we'll touch a little bit on rain gardens as well. But really the starting point is just to kind of orient ourselves to water and some reminders. Really the I don't want to overstate it, but the miracle that is water and the fresh water that we can depend on, only 3% of that is of the entire water on the earth is fresh water. And a lot of that is locked away in glaciers and in groundwater that's not really accessible. And so there's only a small percentage that is able to be used for human consumption. And only a small percent of that that's available. And what impact does kind of our daily habits have? Well, at 1 drip per second, a faucet can leak up to 3,000 gallons a year. So you think about that leaky faucet, you know, maybe we think about it's not such a big deal, but every drip that comes out of that faucet, that's one more drip down the drain. That's a drip of water that's been treated to the level of drinking water that we've lost. And on average U.S. person in the U.S. uses 156 gallons of water each day. So we're going to think about, you know, really what are some ways that we can do, some things we can do to positively affect water resources. And one of those, like I mentioned, is through harvesting rainwater. And there's really 3 things we'll cover today. The aspect of rainwater harvesting for water conservation, for capturing rainwater runoff or reducing the impact of high peak flows and high volumes, which we'll talk a little bit about, and then reducing water pollution, so the actual contaminants within that water. So going back to probably 5th grade or something, for a lot of you all, the water cycle, really a lot of this, you know, anytime it rains in most watersheds, most natural watersheds, a lot of that water is going to become what we call infiltration. So it's going to go down into the ground, and that's what's going to recharge our groundwater. And that's also what feeds what's called our base flow in streams. But then when you look at the water cycle, when you have development or any impervious surface, what really changes that from an infiltration dominated system to a runoff dominated system. So again, if we start over here on the left side where there's no impervious surface, and just to define an impervious surface, it's anything that water cannot penetrate into. So this could be, excuse me, this could be a sidewalk, it could be a roof, it could be a driveway, it could be a parking lot. It could even be soil that's very compacted that doesn't allow any infiltration. And so development, anytime we pave over surfaces, we're going to decrease the amount of water that can get into the soil. And so typically in a natural system, about 10% of our precipitation or rainfall is runoff. And then when we increase just a little bit, then that goes to about 20%. And this would be maybe, you could think about it as like an acreage. This would be maybe suburban area with fairly large lots. And now we're up to 30% of that precipitation becomes runoff. And then when we're in more developed cities, even in Brookings or on the SDSU campus, this would be considered highly developed. Then 55% of that precipitation is going to be runoff. And when you think about the changes that this means for how much water goes downstream and how quickly it gets there, especially in a landscape that's kind of been shaped over a certain runoff regime, a certain amount of runoff that comes year in and year out. And these changes from impervious surfaces can make a really significant change for flooding, for stream bank and stream bed erosion. And so we see a lot of that impact in streams and in rivers and in the amount of sediments and pollutants that are carried downstream. And the other thing that this does is, because we've cut off where that water can enter from the surface into the groundwater, we lose that base flow. And so, like I mentioned earlier, most of our streams and rivers are fed from groundwater. The water table is essentially at the level of whatever the level in the stream or river is. And whenever we cut off that connection between the surface and the groundwater and the base flow, then it also means our streams are much flashier. And so really the only time they flow or flow with any significance is when there is a rainfall event, and then that water gets there much more quickly, and then it also goes down much more quickly. So when you think about that for habitat, you know, really a lot of the fish and the bugs and the turtles and the frogs that need kind of a consistent flow of water in the stream, that's gone now because we've disconnected the surface to the groundwater. And so what can rain barrels do to really address some of these issues? And we'll talk a little bit about rain gardens as well. But if you think about kind of the impact of each individual, a rain barrel in and of itself doesn't do a whole lot of good. But when you multiply that across a city or a community of 1,000 or 10,000 or 100,000, then that can have a really, really big impact. So the first one we'll start with is water conservation. And why do we care about water conservation? Well, from a economic perspective, water is something that we pay for. In my opinion, water is probably not something that we pay enough for, because really we don't value water as we should. And it's only when the well runs dry that we really understand the value of water. But in a very basic sense, conserving water, whether it's harvesting it or putting in low flow shower heads, things like that, it's going to help save us money. It's also going to extend the life and reliability of septic systems. What do we mean by that? Well, anything that comes out of a faucet or out of a shower head, that also has to go into some type of waste treatment facility, whether that's a septic system and in your yard or in your property, or whether that's public infrastructure like a wastewater treatment plant. And so the more water that has to go through those systems, that's more use for those systems, which means you're overall, to some degree, decreasing the life of those systems, because it's more has to be treated. And the last bullet point is essentially, you put less downstream or into the sewage system, then that again kind of decreases the amount of expansion that you need. If you have 10,000 more people move in, but everyone cuts their use by 10%, then you don't need as big of an expansion, or an expansion as soon as if everyone also increases their water use in addition to moving in. And so what good could we actually do? How much could we actually get from a rooftop? So if we have a 800 square foot roof, and this would be, you could calculate this for yourself, but for one rainfall event, that would be 500 gallons. And then if you multiply that over the kind of anticipated amount of rain that Brookings or some of the communities in eastern South Dakota would get, around 25 inches of rain on average, it's about 12,500 gallons of water that you've collected off of a rooftop. Now, we can't use all of that, because some of that comes in the winter in the form of snow. Some of it may come kind of back to back, so our rain barrel would fill up and overflow. But in general, if we were able to capture and use all of that water, it'd be 12,500 gallons. So if we look at just kind of the growing season, if you will, or the active time that you would use a rain barrel, if you run through some average calculations, one rain barrel can save approximately 1,200 gallons from April through September if that's emptied once per week. And then it's not the only way that you can conserve water. There's certainly things that we can do, thinking about watering, landscaping, using more native plants that maybe require less water, even selecting plants that use less water, not just native plants, but selecting ones that are more tolerant to drought conditions. Mulching around plants is going to help reduce some of that evaporation from the soil surface. Watering early in the morning or when it's not hot is going to reduce the loss of water from evaporation compared to if you're watering when it's really hot. And then there's a lot of things that we can do inside our homes as well. And a lot of these are labeled with the EPA WaterSense logo. And these could be toilets, dishwashers, washing machines, shower heads, or putting an aerator on your faucet. And really, all of these individually, they may or may not use a whole lot or make a whole lot of difference, but cumulatively across a home, they can make a really big difference. And then if you multiply that across entire communities, then that makes a very significant difference. And it's whenever you do this, both indoor and outdoor, multiply it across a community, that then you end up in situations where you are realistically able to reduce the amount or the how quickly you have to increase your capacity for infrastructure and things like that, because you have reduced the demand. Other ways you can help: planting trees, installing porous pavers, installing rain gardens, really any way that you can get water into the ground versus having it run off. Those are other benefits. Here's a few examples of rain gardens. And rain gardens are essentially a depressional area that's in the landscape. And you may wonder, how a rain garden could fit in your backyard. Well, there's several examples that really give a kind of a breadth of opportunities for rain gardens to fit in landscaping. This one it's on a fairly steep hillside. It has a dry creek bed coming down. This acts as kind of a sediment treatment. You're able to get the sediment removed, and then it comes into this depressional area. It's planted with these beautiful native plants, some black-eyed Susans and brown-eyed Susans. Excuse me. The one in the top right is actually an interesting example. We had approached, this is from work that I did in Oklahoma. We had approached a landowner about putting in a significant bioretention cell. And he said really he used that area to chip golf balls down into. And so he didn't want to lose his chipping green. And so instead of a traditional bioretention cell or rain garden, we added tiff grass that would be commonly found on a golf green. And then we added these sand bunkers, and then bald cypress trees that would fit on a golf green. In the bottom left corner picture in Brookings, South Dakota, this is at the City County building, and this is a project that Robin Butterbaugh had significant leadership in, and it was a partnership with the Native Plant Initiative. And all of these plants are also creating great habitat for pollinators and a lot of other kind of native flora and fauna. This is in the backyard of a residence in Sioux Falls. And so again, just taking water from a downspout, routing it into this rain garden area, whatever you need to do to make it work. This is another one in Brookings. This is a very small one in OKC, but really just to show that the size and the kind of planting palette are very much up to personal preference. And there's a lot of good that can be done with backyard rain gardens. So another thing that we can do with rain barrels is to capture rainwater runoff. And so precipitation is changing in eastern South Dakota. If you look at two time periods, 1961 to 1990, compare that with the time period of 1991 to 2009, you'll see a significant or a fairly noticeable increase in precipitation across much of eastern South Dakota, eastern North Dakota, and kind of this western Minnesota, and then northeast Iowa. And we see increases of anywhere from 2 to 4 inches more annual precipitation in eastern South Dakota to eastern North Dakota, and then over 5 inches more in northeast Iowa. And so if you think about that, if you're at 20 to 25 inches of rain a year, 2 to 5 more inches, that's a big deal. That's anywhere from 10 to 20% more water falling on the landscape in any given year compared to kind of what the landscape was used to, if you will. We're also getting more intense rain events, 14% more 1-inch rain events, and then the timing is changing quite a bit as well. So this is just looking at timing changes. So we're this kind of similar color scheme. We're getting more in the fall, anywhere from 30 to 60% more precipitation in the fall, and then anywhere from around 20 to 50% more precipitation coming in the winter. And so if you can imagine the challenges of dealing with not just more precipitation, but it's coming in times when we're not able to use it. Really, that kind of increases our need to manage water and increases the challenges. And so, going back to those early slides about the change from an infiltration dominated system to a runoff dominated system, really this is what we see in a lot of urban areas. We have a direct connection between where that runoff is generated on a roof or on pavement and then where it will enter a stream. So a downspout here, downspout comes down from the house, it outlets into the street, and if you follow that drop of water downstream, it's going to go from a curb and gutter into a storm sewer. That storm sewer is going to outlet into a stream or a river. In our case, probably Brookings, probably 6 Mile Creek or the Big Sioux River pretty soon after that. And so in this situation, we're not even going to a curb and gutter system. We're going directly from the roof downspout into the storm sewer pretty immediately. And really, this is what kind of exacerbates this higher peak flow. So the amount of water that's coming through a watershed, as well as that total volume. We're not doing anything to stop or slow down or limit the runoff from occurring in these situations. And so what could we do instead? Instead of that, we could limit that by, instead of just going from the roof to a downspout and then into the storm sewer, we could route that into a rain barrel. Now, that's essentially acting as a miniature detention basin. It holds that water, and then we're able to use that on the landscape over time versus having that just be directly flushed into the storm sewer. And so the other things that we can do with that outside of just using a rain barrel would be what's called downspout disconnection or redirection. So for example, in this situation, whereas this could go from the downspout onto the driveway down into the street and curb and gutter. In this case, they were able to direct it from the downspout into a green space, and then that green space is able to absorb some of that water before it goes downstream. And then there are, from a rainwater harvesting perspective, there's a huge range of applications. Obviously, today we're talking about backyards, but this could be also in commercial or industrial settings as well. Could be used for things like gray water, so this would be flushing toilets. Could be for vehicle washing or to supplement landscape irrigation. There's really a huge range of applications for rainwater harvesting. And then essentially the ability of rainwater harvesting is it's very flexible, I should say, as well. So it could be in a new plan for a new site, or it could be retrofit. I worked with a system as a Coca-Cola distribution facility in Lexington, Kentucky, when I was there working on my master's, and they put in two 10,000-gallon tanks that were used for truck washing, floor washing, flushing toilets, and then landscape irrigation. And they simply retrofitted into their existing facility, didn't have to add any new facility. So it's very flexible. And again, it provides both that conservation of water as well as a reduction in runoff volume and peak flow. So again, it's not just the example of reducing the amount that we're using, but we're also reducing the amount of water that's going downstream. So if in our example from before, 1,200 gallons per year, if 100 homes did that, that's 120,000 gallons that we prevented from going downstream. That's 120,000 gallons of water that aren't carrying hydrocarbons and heavy metals that they're picking up from the curb and gutter system. It's It's not carrying sediment. There's a lot of other benefits that we're getting from reducing that water from going downstream. And then kind of to just build on that, reducing water pollution. So what's called non-point source pollution is basically it's from a large area. We can't pinpoint directly where it's coming from. So like we can't say it's the ethanol plants or the an industry or a commercial setting. It's just coming from across the landscape. And really, how do we manage that? The best way that we can manage that is, again, through individual measures that we're able to prevent individual polluters or individual sources of pollution. So a lot of different examples from this, and actually a big source of a lot of fecal coliforms and E. coli is geese populations in certain areas. I know that was an issue again when I was working on my master's at the University of Kentucky, but it could be a range of things. And again, it's a lot of tiny cuts. Non-point source pollution is, and so how do we manage that across multiple systems? And can have a pretty negative impact. It can impact fish and wildlife. It can impact recreational water activities. So you get algal blooms and fishing, and so it can have a pretty significant negative impact. So rain barrels again are one way that we can, and rain gardens are one way we can reduce that non-point source pollution. So let's get back to rain barrels. Kind of some, if you put a rain barrel in, what are some of the how-tos? So really the bottom line, or maybe the biggest take home, is it's non-potable water. You should not be drinking or cooking with this water. Maybe, like the best uses would be irrigation and some applications of washing, whether it's patio or getting mud off your boots, those types of things. And then if you kind of want to step it up a level, you can use it for gray water applications of flushing your toilets and things like that. Because this is a standing source of water, you need to make sure that that's screened or sealed to prevent any mosquito issues. Especially in South Dakota, you'll want to be sure that's drained and winterized. So essentially just drain it, maybe move it away from the downspout, so it's not gonna have water in there that freezes and cracks. And really, it's best suited if there are existing gutters and downspouts. There is a wide variety of styles and sizes available. And the other big thing from a kind of maintenance or use perspective is that water needs to be used or flushed regularly. The longer it stays in there, the more likely you have, say, leaf litter and things like that, that's going to break down. You might, it's stagnant water, so you want to keep that used. So some of the benefits, really, this is essentially natural rainwater, and it's going to be pretty good for your plants. You don't have to worry about, a lot of mineral content in your water if you're pulling from groundwater. So you're less likely to get any buildup of salts or things like that. And I mean, this is kind of an idealistic situation, right? But it gives you kind of one more tool to protect landscape plants during times of drought. And so even if your community gets hit with watering restrictions, if you're in a drought, then you're able, if you do catch any timely rains, you're able to hold on to those and use that water to water landscaping. There's been a lot of kind of discussion and questions about whether you can use harvested rainwater on edible, it's like vegetable gardens. I would recommend to not put it on anything edible, so not use it on root crops, not use it, not actually get it on any of the fruit itself. But I think it would be fine. I haven't seen a lot of evidence of any uptake of chemicals or anything kind of through the plant in rainwater harvesting situations. Maybe, watch the dog. I don't know if that's, you want to kind of keep an eye on that. If the water's seeming kind of questionable, then probably don't want to do that. But, definitely can use it for other applications. And then again, kind of keep a regular turnover from that rain barrel, both to keep the water fresh, as well as if you're able to get rid of the water prior to a rain event, then you're doing your part to reduce runoff downstream. Otherwise, that water is just gonna overflow, and then you're not really doing anything to reduce the runoff downstream. So again, just to reemphasize, do not use the rain barrel water for any cooking or drinking. It's for non-potable uses only. And then also, if you suspect or if you have applied anything to your roof, then you definitely want to be careful that you don't want to use potentially chemical laden water on an application that so if you have a moss killer, that could have negative implications for plants if you end up using that water on the plants. The other thing, as I mentioned, mosquitoes are, this is a real potential risk if that rain barrel is not sealed or screened. And so if you have water coming in and there's an opening there, then that's an opportunity for mosquitoes to lay eggs. And then now your whole neighborhood is, all your neighbors are unhappy because you're the source of mosquitoes in the neighborhood. Now, we've had a rain barrel the last probably 2 or 3 years, and it's very similar to the one shown in the picture. The water comes in to a screen in the top, and then it comes into the rain barrel from there. And that screen does two things. One is it keeps the big, leaves and sticks and things like that out of the rain barrel. But the other big thing is it prevents mosquitoes from being able to actually get down into the water and lay their eggs. So there is some recommendation to just kind of general maintenance recommendations for the screen. Keep that in and just keep an eye on it, right? If it's maybe getting corroded, a little rusty, things like that. If it's a metal screen, if it's made of a different material, just making sure there's no tears in it. And if it's doing okay, if it's intact, if it's not impacted in any way, then 2 years is, you can probably keep going beyond 2 years. It is recommended to remove debris from the screen after storms. And the reason for this is you don't want to limit flow into the rain barrel. You can imagine if you have a lot of debris on the screen, and then that prevents water from going in the rain barrel, then again, you've kind of lost your ability to capture the water. You don't want to keep this going over the winter because, again, water will get in there, it'll freeze, it'll crack. This happened to a friend of mine, and now they have a fancy barrel with a crack in the side that doesn't hold any water. It is not a bad idea to clean that out after the season is over. To be honest, I'm not that consistent about cleaning ours out after the season, but the nice thing is if you do clean it out, then you're going to have less kind of build up over time, and it's also going to keep the mechanism, the faucet, working better as well. So how do you actually install this thing? So the first thing is you're going to need to find an appropriate location where you have a downspout that can be cut or modified, and then a stable place that that rain barrel can rest on. And so first step is to level the dirt under the downspout. You can add sand, gravel, crushed stone, basically something to provide some structural stability there. Remember that um, water is, water has weight, and if you're holding 50 gallons of water, that's a fair amount of weight. And the other thing is you need to get that up off the ground, or some way to get a watering can underneath, or some way to actually get the water out to be able to flow out into a container. And what we did is we just built a little platform with bricks, very similar to what's in the picture here. And then that gave us enough clearance that I can get a watering can under there, take it and water the plants. Yeah, so 50 gallons, it's almost 400 pounds. So definitely want to make sure that that has some structural stability. Don't want to just do it on necessarily loose dirt, or dirt that, or a lot of clay that is maybe kind of has a tendency to slide, or things like that. So you want some structural stability there. I don't think you necessarily need to go all the way to concrete, but it's certainly also a possibility. But bricks or cinder blocks, really anything that is going to give you some structural stability and distribute that weight. So the next step is to figure out how high your rain barrel is going to be, and then just measure and cut that downspout. You'll need to make sure you have the appropriate fittings to go from the cut downspout to whatever is going into your rain barrel. But it's honestly, it's pretty easy. And if you've ever done any type of home improvement, then it's definitely an easy thing for you to be able to install one of these. So another option for this is what's called a first flush diverter. And the way a first flush diverter acts is, so I should say there's actually two diverters. This is basically a valve or a switch that you can switch it from either flowing into the rain barrel, or you can switch it to going kind of the normal route. Some people like to do this because that way they don't have to kind of redo stuff each year. They can leave the rain barrel out there. And also, if they need to remove the rain barrel for any type of maintenance or anything, they can just flip it one way or the other. Now, there's another thing called a first flush diverter. And the way that works is essentially, if you think about the amount of water, or the first flush of water that comes off of a roof, that's going to be the dirtiest. It's going to pick up the most most dust that's settled on the roof, things like that. And so the first flush diverter is actually able to divert that away from the rain barrel. So what you're actually capturing is the cleanest water into the rain barrel. The one that's shown here is just a kind of an overflow diverter, which I don't know, it's nice, I guess, but it's not a huge benefit, because most of your rain barrels are going to have some type of diverter built in. But those are some of the options. And then, again, just a reminder that it's important to kind of winterize your barrel. And you want to make sure that the water is drained. There was one year that we waited a little too long, so we had some water in the bottom that had frozen, and I was able to heat it up and make it melt down some, and then dump it out. But then we had a block of ice sitting in our backyard for months, I think all winter. But so you want to drain it. We store ours in a shed out back. It's not critical that you store it indoors, but you do want to make sure that it doesn't have any ability to get water actually into the rain barrel through the winter. Um, and then again, you also want that water to be able to go somewhere while the rain barrel is not there. So just to make sure you've kind of got your bases covered on that. So yeah, I mean, really the big thing, just to kind of recap, rain barrels, you're instead of water going downstream um, from the gutter to the downspout to the curb and gutter into the storm sewer, you're collecting it off the roof, capturing in a rain barrel. You can kind of see here, I should have shown a better picture of it, but these are actually kind of daisy chained together. So one rain barrel will fill up first, and then you can actually connect these where it will go from one into the next. And then once this one fills up, it will go to the overflow. But kind of the big components are, you want to have enough water capture that you're able to use it for your uses, and you're able to reduce that amount of water going downstream. You want to have some type of cover with a screen to keep out those large debris, and as well as prevent mosquitoes from breeding. And then you need some type of faucet mechanism that's high enough off the ground that you're able to get some type of watering can underneath it. I will say this particular model, one downside of this is the one upside is your faucet is higher up, so you don't need as much of a kind of platform to put the rain barrel on. But the downside is the water underneath the faucet, underneath the spigot, is not available unless you tilt your rain barrel forward. So you're not able to easily empty this all the way down to the bottom unless you actually have to move the rain barrel. One benefit of that, though, is the closer it gets to the bottom, the more likely it is to pick up some of the stuff that's settled out. So sediment or any of your organic matter, things like that, or even asphalt coming off the shingles and things like that. And that's all I had. So happy to take any questions if there are any questions.
There are definitely a couple questions. First one is, can rainwater be used for livestock?
Yeah, that's an excellent question, actually. And so I've thought about some applications for kind of larger scale agriculture. I would definitely want to test that water before you commit to using it for livestock. But I think there's some applications in larger scale agriculture for livestock or for spraying applications. So a lot of times, if we're mixing up chemicals to spray, and whatever our water source is, it maybe have a high mineral content or other things like that. Well, rainwater may be a good kind of complement to use, that we're not going to interfere with the it's not going to have high calcium or something that's going to bind to whatever the pesticide is, or whatever the chemical is. But for livestock, I would say definitely test that. And the biggest things I'd be concerned about is if there are, say, a lot of say like migratory geese. And actually the one in Kentucky that I worked on, they had a migratory goose population that kind of nested on the roof, and that's not a good situation because there's a lot of goose grease that ended up kind of initially in the first rounds of water that came out of those rainwater harvesting tanks. The other thing to think about would be what type of material the roof is made of, and if it's likely to have any type of heavy metals or things like that actually in the water. But yeah, I'd say get it tested, but I mean it should be pretty good, and for a lot of reasons. But you're probably going to also want a lot bigger tank than just a 50-gallon rain barrel.
And question number 2, is there a practical way to get the water from the barrel to your flower beds? This question asker ended up having to use a bucket, and that ended their rain barrel project.
Yeah. So I've used the watering can, which is not conducive to like using drip irrigation or things like that, obviously. So really, if you want to use a hose, what you're going to need to do is you need more elevation in essence. So that water's going to have to be higher up, so you have enough head or enough pressure to be for that water to be able to push through that hose. So yeah, that's the big thing, and it's probably not the time or place to talk about kind of how you calculate that, but basically, I mean, yeah, I'd say look online and look at some of the conversions between the height of water, and basically you want the difference between the height of the water in the rain barrel and where it comes out of the hose in your garden. And if you have enough fall, then you could very realistically, practically use a hose to get that done. But it probably involves building some type of platform that's higher up for that to happen. So it may not be feasible or worth it. You can also use a pump, but I mean, like, you can do anything, right? You can make anything work, but the more you have to invest into it, the less likely that it is that it makes it feasible for you. We did a project last year. It wasn't in the ground, but we looked at rainwater harvesting for high tunnels, and more so the feasibility of doing that at 12 different locations across the U.S. But Iowa State University Extension has a really nice high tunnel rainwater harvesting video that also talks through kind of there's a solar pump that they put onto that. And I think they use drip irrigation for that as well. So, I mean, it's definitely doable, but it's going to be more involved, and it just depends on how much you want to invest in that.
And let's see, question about what is the major difference between well water and water out of a rain barrel other than the debris off the roof?
Yeah, so a lot of times well water, depending on what the geologic formation that the water is coming from, it could have a pretty high mineral content. And I mean, you think of some of the well water that, especially out in the Black Hills or even in eastern South Dakota as well, a lot of that's almost brackish, so really high salt or mineral content. And initially, that may be okay, but the longer that gets applied on a soil, then that's going to build up, and it's going to build up to the point that your plants aren't going to be able to grow because of that high salt content. It's essentially going to become saline or sodic. So depending on and then again, like some well water doesn't have that issue. So it would kind of depend on the quality of water, excuse me, from the well. A lot of times your well water is going to be hard water. So rainwater is going to be soft water. Rainwater is going to be slightly acidic, so pH slightly under 7. Well water could be sometimes basic, could be, yeah. So it really depends on the quality of the well water, but those are going to be the most common I guess, issues if you do have issues with well water.
Is there a specific filtration system that you can attach to a rain barrel?
Yeah. So there are some, and again, it kind of depends on your use. Um, but the biggest ones would be on the downspout itself, and it's going to be some type of screen essentially. So the one that I worked on, I didn't install it; it was more monitoring. But the one that I worked with in Kentucky, um, they had a coarse filter and then a fine filter, and they also had that first flush diverter. I mean, so they had the whole 9 yards for a filtration system, but backyard gardeners, absolutely, you can get pretty basic screening and kind of filtration, not like a sand filter or anything like that, but pretty basic filtration that would attach the downspout or be in conjunction with the rain barrel.
And let's see, do you know of any grant programs available to convert over to rain barrels?
Yeah. So actually, in Brookings, the city of Brookings is doing a program, and Robin actually would know more about this as well, but to cost share rain barrels for folks in Brookings. Um, a lot of times in South Dakota, it's going to be more kind of municipality specific. Um, I don't think there's anything at like the federal level, any cost share or cost offset. Um, yeah, but maybe Robin, you could just share about the Brookings one.
Yeah, sure. So just this spring, with the implementation of the new stormwater master plan, Brookings set aside some funds for a stormwater incentive program. And so with that, they have kind of offset the cost of rain barrels. So they're providing a $30 discount on the first rain barrel, and it's for Brookings residents. And then they're also providing a 50% reimbursement on the cost of different native plants with a minimum purchase of like $125 up to $250. But for the rain barrels, there's actually a website on the city webpage that people can go to purchase those rain barrels. So they buy the rain barrel outright, and then for the first 100 rain barrels, there's a $30 discount automatically applied. And then people can actually buy more rain barrels than that if they want to. There's really no limit. And then those rain barrels are going to be available at a distribution event, I believe, on June 8th. But yeah, the cost of the rain barrels, even without the discount, is pretty reasonable compared to some that you can find at a lot of the home stores. So it's a pretty good program. We're kind of just piloting it this year to see how it goes, and looking forward to seeing, what people think about it. And I'm also interested in the native plant aspect of it too, but
Thanks, Robin. And honestly, I think you as a member of a community can make a difference in, even inquiring to your whatever community you're in if something like that is available. If it's not available, then hey, you can point them to the Brookings website and say, well, when are we gonna do what Brookings is doing and get some rain barrels of our own? But
Yeah, and folks, if you have any other questions, feel free to throw those in the Q&A. We do have the 2 links in the chat for the surveys. One is for this webinar specifically, and then the second link is an extension research needs assessment to help us out as we're preparing to write some big grants for 2025. So we'd appreciate your input on both of those surveys. And we've got some links here from John. Yeah, Twitter, X formerly known as Twitter, and podcast and email. So feel free to take down his contact information. Yeah, we'll be back next week on Tuesday at 12:30 Central, 11:30 Mountain with the Grasslands presentation. And then Thursday will be Robin and I talking about biodiversity. So yeah, Robin or John, any last minute announcements?
Nope, I don't think so, but just we really encourage people to take those surveys. They're really super short, so very painless.
Yep. Yep. We appreciate all sorts of feedback so that we can, better serve the citizens of South Dakota with our programming. So
Yep.
yeah, and thank you again to John McMaine for joining us today. And I'm definitely going to be doing some more rain barrel research to see what I can put up at my place here in Pierre. So
Sounds
I'm
good.
looking forward to it.
Awesome.
All right. Yep. Thank you, John.
All right. Well, thanks everybody, and we hope to see a lot of you on Tuesday. And if not, check out the recordings on our YouTube channel. So thanks so much, and we'll see you next week.
Yep. Bye.